Hello everyone, welcome to another episode of our VODCAST, and today's topic is quite interesting because we are going to discuss about Spacetime Continuum. But since a lot of you guys suggested in our comment box to also discuss about black holes, and since the topic is also interesting and related to Spacetime Continuum, so I asked my partner Syra here to discuss about black holes, while I'll be the one to discuss about the Spacetime Continuum.
Hello everyone, welcome back to our podcast. And as Spencer said, I will be the one to discuss the most suggested topic, which is black holes. So this podcast is a very interesting one since we are going to discuss two topics. So Spencer, don't make our viewers wait and discuss right away what is space-time continuum.
Yes, okay, here we go. Remember in our previous podcast about relativities, Einstein published his special theory of relativity, right?
Yes, I remember that.
Einstein didn't really call that theory a special theory of relativity. The name of the paper was actually on the electrodynamics of moving bodies, and no one wanted to recite that, so it's just called special theory of relativity. But that's what it is because it's about relativity of motion and time. Now, we know that we have these three spatial dimensions, right?
Yes, the length, width, and height.
Yes, those three dimensions. Every object that we see has three dimensions and it has length, width, and height. We are 3D individuals. Now, Einstein suggested in his theory of special relativity that there is actually a fourth dimension. And that fourth dimension is time. He suggested in his theory that time and space are interwoven, and that is what we call space-time.
Can you elaborate this further, Spencer? How are we living as four-dimensional beings?
Okay, for example, if I ask you, Syra, let's meet up at the ER Mall, what would you say?
I would say, okay, sure. What time?
There, see, you are asking for time. And when someone says, let's meet up at 8 a.m., you would ask for the specific place where you would meet up. That is what it means for time and space to be interwoven. Einstein's mind is simply amazing because no people actually thought of that we are living as four-dimensional individuals. And this thought actually brings about many other thoughts like, is it possible to make a time machine and get to the past or to the future? But naming it time machine is just wrong, right? Since time and space are interwoven.
So it should be called a space-time machine.
Exactly. You can't go back to the past without pinpointing out the exact location where you are going to in that certain point of time because the earth and everything else is moving. But I think we're straying off with our main topic. I think time machines can be another topic for our future podcast. So going back, as I've said, space and time are interwoven. But what I've discussed is just barely scratching the whole thought of the space-time continuum. The example I've given is merely explaining how reality is a three-dimensional place that evolves in time. The right thought would be combining space and time to make a single entity called space-time. What is space-time? Space-time refers to whatever external reality underlies our collective experiences of the space between things and the time between events. However, our experiences in measuring time and space does not correspond with anything. Space-time is a four-dimensional non-Euclidean mathematical space that's just there. There's no time and space, but space-time. Okay, so I guess I will end it here. It's now your turn, Syra, to discuss the mysterious thing called black holes.
Thank you, Spencer, for explaining to us what space-time continuum is. Albert Einstein's mind is indeed really amazing, no doubt. No wonder he's the most celebrated scientist of all time. Now, let us discuss black holes. Black holes are among the most fascinating objects in our universe and also the most mysterious one. A black hole is a region in space where the force of gravity is so strong not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return beyond which we truly cannot see. When something crosses the event horizon, it collapses into the black hole's singularity, an infinitely dense and infinitely small point where space, time, and the laws of physics can no longer apply.
Oh, so that is why many sci-fi things are related to black hole, like how people could use it to travel to super distant places or travel through time. Turns out black holes are still full of mysteries.
Yes, the fact that no light can escape through the black hole made it hard for scientists to study. That is why black holes are still a complete mystery. Moving on, scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. Stellar black holes formed when massive stars die and collapse. They are roughly 10 to 20 times the size of our sun and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions times more massive than our sun. Scientists can only guess how they are formed, but we do know they exist at the center of just every large galaxy, including our own, which is the Milky Way. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter of about a distance between the Earth and the Sun. Because black holes are invisible, the only way for scientists to detect and study them is to observe their effect on nearby matter. This includes accretion disks, a disk of particles that form when gases and dust fall toward a black hole, and quasars, which are jets of particles that blast out of supermassive black holes. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.
Thank you for that wonderful explanation about black holes, Syra. To our viewers, thank you for watching our VODCAST.
And if you want for more discussions about science, let us know in the comment box. See you on our next podcast, everyone. Bye!